Okay, we are working on your purple packet, Unit 2, Cycle 3, the Learn for steep and less steep. So today our graph is going to change slopes. Last time it changed the x and y intercept. So first, our linear parent function is graphed for us. We know it's the linear parent function because it goes through 0, 0, and it goes up 1 over 1, up 1 over 1. So the slope is 1, the y-intercept is 0, 0. Remember, if we plug in a 0, we will get out a 0. So each time we plug in a number, we get the same thing. So I can complete my table by putting a 4 and a 5. And that is our linear parent function. Okay, so now what we're going to do is we're going to change this up a little bit. We have a new formula, g of x equals f of 2x. So we're going to take 2 and multiply it by our x's. So we're going to take the x, we're going to plug that x in, so 2 times 0 is 0. So I started with an x of 0, I ended with a y of 0. I'm going to do the same thing. So now I've got 1, I'm going to plug in a 1, I get 2, so I plugged in a 1 and I got out a 2. I'm going to plug in a 2. So my 2 over here, I plug it in. 2 times 2 is 4. So I get 2, 4. And I'm just going to continue my table. So if you would like to stop and pause it here so you can try the table out, go for it. Then you can pick it back up and see if you got it correct. So I am just plugging in the rest of my x values. Okay, so we have all of our x values and our y values in our ordered pairs. We're going to now graph these ordered pairs. So I start with 0, 0. I plot the point 1, 2, then 2, 4, 3, 6, 4, 8, and 5, 10. Now, when you draw a line through these points, you don't just draw a teeny baby line. You draw a line that goes all the way through the graph. Arrows on both sides to show that it goes on forever. And we have a new line. So let's talk about this line and see what's different. Let's look at the slope of our line. Start at this point, we go up 2 and over 1. So our slope is 2 over 1, which also means our slope is 2. Our y-intercept is where it crosses the y-axis. We still cross at 0, 0. So if you look at our equation, we didn't subtract or add in the inside or on the outside, so we didn't move the intercept, but we did change our slope. So this number right here ends up being our slope. So now let's try the same thing and let's see if on the outside it's the same thing. So remember, f of x stands for y. So it's like 4 times y. So what we're going to do is we're going to take our y values now from our table and we're going to plug them in. So 4 times 0 gets us 0. So we've got 0, 0. I'm going to plug in a 1. And I want you to continue your table. So we're going to keep taking our y values and plugging them in. I make the point. If you need to pause this video, pause it and get caught up, or maybe get ahead and see if you're doing this correctly. Remember, we cannot help you on your test. So make sure you've got it down. So now that I have all my points, I'm going to do the same thing. I'm going to graph. So I start with 0, 0. Then I plot the point 1, 4. 2, 8. And I can't plot 312 because it's off my graph. So I have 3 points. That's good. I'm going to draw my line. All the way through my graph, I've got arrows on the ends. And let's describe this graph. So our slope, if we were to look at the slope, we start with this point. We go up 4 and over positive 1. 4 divided by 1 is 4. Our y-intercept, our b value, we're going to see where it crosses on the y-axis. Crosses at 0, 0. If you notice, our slope is still 4, and that's the number we saw in our equation. So whether it's on the inside or the outside, it's the same. It's our slope. So let's talk about how the graphs are similar and how they are different. So our graphs both had a y-intercept of 0, 0. Okay? They both had positive slopes. They were different because they had different slopes. Yes, we were both positive, but they were different. And it was really just how it looked. So one of them had the number on the inside, and one of them had the number on the outside. But they did the same thing. So what do we notice about these slopes? Like we said, they're both positive. This is something you may not have noticed, but they are also both greater than 1. Or we can use the symbol greater than 1. The reason we're comparing it to the number 1 is the LPF, or the linear parent function, has a slope of 1. So when we do new graphs, we're trying to compare our new graph to the slope of 1. Now the last part says, how does the change in slope affect the steepness of the line? When you think of steepness, I want you to think of a mountain. Either thinking about hiking a mountain, or skiing, or sledding, or something down a mountain. Okay, so when we look at this graph, if I were to go skiing down this mountain, this black line, I'd be going pretty fast, right? The steepness of this line, it's pretty fast. The steepness is 1. That's our slope of 1. Now, if I went skiing or sledding down this purple line, I would definitely be going faster. So both of these graphs, if you look at both of them, this one is steeper than our black line, and so is this one. They're both steeper. So when slope is greater than 1, the line is steeper than the linear parent function. So that word we're looking for is steeper. Our line got steeper. We'd be going faster down that mountain. Pause it if you need to catch up. So on the back, now we have something else happening. So we still have numbers on the inside and numbers on the outside, but now this one is 1 over 2, or 1/2, and this one is 1 over 3, or 1/3. So we're going to see how that changes our graph. So the same as before, we're still multiplying a number. So I've got 1/2 times, I'm going to plug in my 0 for x, because I am looking for things to plug into x. So my point, 0, 0. I've got 1/2, plugging in a 1. Now if I plot points, it's really hard to know where 1/2 is. So I'm going to change it to a decimal. So 1/2 as a decimal is 0.5. And remember, you have your calculator, so type this in your calculator to get your decimal. 1, 0.5. I am just plugging in my x values as I go down this table. Every so often when I get a fraction, I need to change it into a decimal to make it easier to read. I've got 1/2 times 4, which is 2. So my last point, I'm plugging in a 5. I get 5/2, which turns into a decimal of 2.5. Okay, so now I have all my points, so I'm going to try to graph my line. Now, you can graph decimals. If I go find 1.5, I can graph that, but it's kind of hard to see. So I am just going to graph the whole numbers. If I graph these whole numbers correctly, these points should be somewhere on my line. So I'm going to start with 0, 0. I'm going to go over and find 2, 1, and then 4, 2. Okay, I'm drawing my line and I'm trying to see if I can figure out what is happening now that we changed and we're now using 1/2. So I'm still going to write my slope and my y-intercept. So my slope, I went up 1 and over 2, which, hey, that was the number we had in our equation, so that's good. Our y-intercept, we're still going through 0, 0. So, looking at this line, if I were to ski down the black line, which I've been skiing all day, this is pretty fast. Our other one got faster than this, but if I ski down this new line, I'm actually going to go slower. So we're going to call that less steep. It's less than our parent function slope or steepness. Now, we've done a lot of these tables, and I really do not want to do another one. So let's try to graph this without doing the table. If you would like to do the table, go for it. But we know there's a pattern. I know my slope was 1/2, and I got it from my equation. So I'm going to try to use 1/3 as my slope. On all of these, I have not added or subtracted anything to the back half of this, whether inside the parentheses or outside. So my y-intercept is going to stay 0, 0, and my slope is going to be 1/3. So I'm going to start at 0, 0. My slope is +1, so up 1, and +3 would be to the right 3. So up 1/3, up 1/3. So I just used my slope to plot new points. So I'm going to take a straight edge. I just have a note card. I draw my line all the way through. This one is also less steep. If I were to ski or climb, it is not as steep as the original mountain. So how are these graphs similar? They are both less steep. And we'll say from or than the linear parent function. How are they different? Well, the only reason that they're different is that their slope is different. And once again, it's the placement of the slope. So one of them had the slope on the inside. The other had the slope on the outside. So, like we said, it did the same thing, but a little bit different. Looks different. What do you notice about the slopes of both equations? I know a lot of people want to say a fraction. Yes, you're right. They are both fractions. But it's more specific than that. So we're going to say both slopes are less than 1 and greater than 0. So this is the less than symbol. This is the greater than. And the reason that's important is because negatives on the other side of the page are going to be something different. So we're going to use a negative for something else. But if you're just looking at the number of the slope, not the sign, we want to see if it's less than 1 and greater than 0. The reason we say this is because there are some fractions, like 5 over 3. 5 over 3 is a fraction, but because the numerator is bigger than the denominator, this is not less than 1. It's greater than 1, so it would be steeper. That's why we have to be specific. Both of our slopes are also positive. That's going to be important, like I said on the next example. So how does the change in the slope affect the steepness? When slope is in between 0 and 1. So slope is greater than 0, bigger than 0, and smaller or less than 1. Our line is less steep than the linear parent function. So we're always looking to compare it to our linear parent function, which is this black line. Okay, last page. Looking at this last page, you're going to notice that there are no numbers visible. We have a negative x and we have a negative times f of x, which we know is like a negative times y. So we know that if an x doesn't have a number in front of it, it's really a 1. So this is like negative 1 times x. So I'm going to fill out my table. I am simply going to take negative 1 and I'm going to multiply it by my x value. So from here or from here, and we get 0. On all of these, we have not changed the y-intercept. The next one, I'm going to plug in the next number. So plug in a 1. We get 1 comma negative 1. Negative 1 times 2 gives me negative 2. 2 comma negative 2. I hope you're seeing a pattern here. When I plug in a 3 and I multiply it by a negative 1, I should just get the opposite of 3, which is negative 3. So let's think about this. If I plug in a 4, I should get a negative 4. We're just changing the sign when we multiply by a negative 1. So I have all my ordered pairs. I'm going to plot 0, 0. I'm going to plot the point 1, negative 1. So I went to the right 1 and down 1. My next point is 2, negative 2. 3, negative 3. 4, negative 4. 5, negative 5. So I've got all my points. I'm going to graph my line. So what do you notice about this? This is our linear parent function, our original line. This line suddenly flipped and became this line. Let's look at our slope and see if that can help us compare these. Our slope is down 1, positive 1. Down 1, positive 1. We've got negative 1 over 1, which means our slope is negative 1, which we saw up here in our problem. So we know that's correct. Our y-intercept is still at 0, 0. That's where we are crossing the y-axis. So all this really did was it flipped it. Our linear parent function was slope of 1. Now we have a slope of negative 1. Did the steepness change? If I ski down this slope, is it the same as skiing down this slope? Yeah, just a different direction. Let's try and see if the negative on the outside changes anything. So this is a negative 1. So negative 1 times y. Now, Just like on the other page, we know that this is going to be our slope, this -1. So m equals -1, and I haven't changed anything on the outside over here, or on the inside. So my y-intercept is still 0, 0. So I'm going to start at 0, 0. I plot this point. My slope is -1. I'm going to go down 1, positive 1, down 1, positive 1. I'm going to plot a couple points. I plotted 5, but you could do 3, 4. As long as you have 3 points, you're good with a line. Okay, looking at these two graphs, they are exactly the same. So it didn't matter if the -1 was on the outside or if it was on the, inside or outside. It was the same. So how are these graphs similar? Same slope, same y-intercept, same line. How are they different? Well, they're not. What do we notice about the slopes of both equations? Well, they are both negative, but they're both also 1. So the steepness of my line is still a 1. It's just the negative has made it change direction. So we're going to say steepness is the same. Only the direction changed. I'm still going to go super fast down this slope, just as fast as I'd be going on this one, but I'm just going a different direction. I'm going negative direction now. So earlier I said this is like we flipped it. We took it and we flipped it. The real math word is called reflection. So when our slope is negative, it is a reflection of the linear parent function. So you need to pause it, copy that down. I'm going to do one example on your practice with you, or on your demonstrate, so that you know exactly what you're doing. For this first one, the first thing we're going to do, we're looking at this number right here. That number, it's our slope. So m equals 3. And to turn it into a slope, we can make it into a fraction. So 3 over 1. Now, I have not changed, gone up, down, left, or right. So I am still at 0, 0. I'm going to use my slope, positive 3, 1. Positive 3, 1. I'm going to make at least 3 points. 2 points doesn't always cut it. So I've made my 3 points. I'm drawing my line. First it asks me reflection. Do I have a negative? Nope. So that means I did not reflect. Did my line get steeper or less steep, or did it stay the same? Because we have a number that's greater than 1, it is steeper. So that's exactly how you're going to do all of these problems. If you have any questions, please come into tutoring or ask your teacher, and study for your test. Good luck!